Hey everyone. Ever wondered what's really going on inside your applications, especially when they're running in the cloud? That's where the concept of observability comes in. Simply put, observability is all about understanding the internal state of your systems by examining the external outputs it produces. We call these signals logs, metrics, and traces. It's like being able to ask your application, how are you doing? And actually getting a detailed and understandable answer. Now, if you're running applications on a platform like Heroku, you know it's fantastic for getting your code deployed and scaled easily. But when it comes to monitoring, especially with modern distributed applications like microservices talking to each other, things can get rather challenging. How do you track a request as it hops across different services? How do you pinpoint a bottleneck when so many moving parts are involved? Traditional monitoring might give you pieces of the puzzle, but getting that complete picture, that true observability, can be a real headache. This is where OpenTelemetry, or OTel as it's often called, steps into the spotlight. OpenTelemetry is an exciting open source project and rapidly becoming the industry standard, designed specifically to tackle these challenges. It provides a unified way to instrument your applications, meaning you can add code to generate telemetry data. It then helps you collect and export this data, your traces, your metrics, your logs, the signals, to your monitoring or analytics tool of choice. Think of it as a universal language for all application performance data. In this video, we're going to dive into how you can leverage the power of OpenTelemetry on the Heroku platform to gain deeper insights into your applications, troubleshoot your issues faster, and ultimately build more reliable software and get more sleep. So let's dive in. So what exactly is OpenTelemetry? Well, OpenTelemetry isn't just one thing. It's a collection of APIs, SDKs, tools, and integrations. It's an open standard, vendor-neutral project governed under the Cloud Native Computing Foundation, the CNCF. The CNCF also hosts Kubernetes and Prometheus. Now, its primary goal is to standardize how telemetry data is collected and transmitted to your backend of choice. This means that you instrument your code once, and then you have the flexibility to send that data to anywhere you want. Okay, to fully understand OpenTelemetry, we need to dive in a little bit deeper to each of the signals. Let's start with traces. Imagine a request is coming into your application. Traces allow you to follow the journey of that request as it moves across the different services. The key concept of a trace as it moves through your system is called a span, which represent an individual unit of work, typically some API call from service to service. However, developers also use spans to instrument functions within a single service. Traces are invaluable for debugging the latency or time spent communicating with other services or functions within your system. Then we have metrics. These are just numeric values taking over time, a sample window. Think of things like counters. Maybe you want to count the number of requests that come into your system. Then we have gauges. This is where we have values that move up and down over time. Think of the memory usage within a Linux machine or a container. And then we have histograms. These are for distributions. These are values that we can put into buckets. Maybe we want to understand the P10, 50, and 95 of all HTTP requests within a system. Lastly, we have logs. These are a time-stamped series of events that happen within your system or application or services or functions. This is like using console.log or the equivalent in whatever programming language of choice you're using. Now, you're probably already familiar with logs, and OpenTelemetry provides ways of collecting logs as well as all the other crucial signals that we need to observe an application. Correlating these makes it easier to pinpoint the exact error, message, or event specific to a slow request, allowing you to debug, remediate, and sleep. Next, let's talk about the key architectural components of OpenTelemetry. First, we have the OpenTelemetry API. This defines how your application or the SDK you're going to use, we'll cover that in a minute, interacts with OpenTelemetry. It provides the calls that you use to create traces, record metrics, or emit logs. The API is designed to be separate from the implementation, meaning your code against the API. That just means you'll be using the SDK and not the API directly. Now, the SDKs exist for many languages. It doesn't matter if you're writing in Java, Ruby, Python, Node, Go, Rust, anything. There's likely an OpenTelemetry SDK that you can use today. It handles the crucial tasks like configuring how your telemetry data is processed. That could be sampling of data. And how it gets to your backend, the database or analytics engine that you'll be using to store all of this data. Now, when we transfer this data over the wire, we use something called OTLP, that is the OpenTelemetry Protocol. It's the universal language for transmitting telemetry data, and it's the standard used for all of the signals that we've already mentioned. Then we have the collector. The OpenTelemetry collector is a powerful standalone service or agent. It can receive the telemetry data from your SDKs, process it, like by batching data for efficiency, filtering out noise, or adding extra metadata, and then export it to your backend system. All right, that's enough of the chat. Let's get hands on the keyboard and see how this works. Here I have a terminal. I have the Heroku CLI installed via npm, like so. I'm going to do local web, which gives me a dev environment to browse my application, which we'll take a look at in a second. And because I'm talking too slowly, we can already see some instrumentation happening. We pop over here, we can refresh, and we see hello world. I have also added a roll dice endpoint that every time we refresh, we get a new number. If we pop back to the terminal, we'll see lots of trace information. So let's stop that, and we're going to run it again. However, this time we're going to filter or roll dice, and we want to see 5 lines after the fact. So now that that's running, let's roll the dice as many times as I can press in a few seconds' time. Now if we pop over here, we can see that as well as all of those traces and log lines that we were seeing, which is a little bit overwhelming, when we grep it and filter it, we'll see that our code is instrumented, and we'll see this in a second, that every time we roll the dice, we have a new counter for each number that is incremented. So let's take a look at the code. So let's pop open main.mjs. Now, most of the magic happens in this OTel file, which we'll take a look at in a moment. It's mostly boilerplate. There's not a lot you need to know about. This is a simple Express application, and we're pulling in the metrics We're pulling in metrics from the OpenTelemetry API because we want to expose some custom application metrics and not anything else that can be determined from the runtime. Down here, we say that we want to get a meter, and this meter is called roll dice meter, and then we create a counter for each of the numbers that it is possible for us to roll. We're being good OpenTelemetry citizens and providing a description. Not all metrics are named as you would expect. We have the worst code in the world for generating a random number, and we have 2 rather crude endpoints on our Express application. One which says hello world and also says console info home. Another which is roll dice, which says info roll dice. It then generates a random number, and then if you roll a 6, we actually console error. Now, the console types that we're using here will become a bit more apparent and useful as we explore pushing this data to a telemetry drain. Anything else, we just do a warn and say you rolled a number, but it wasn't a 6. We increment the counter for the number that we rolled, and we send a response. There's not a lot happening here. In our OTel.mjs, we are pulling in the SDK for Node, the Trace SDK, and the Auto Instrumentation. Luckily for us, the fine contributors of the OpenTelemetry project have instrumented, or at least provided auto instrumentation for a number of their SDKs, meaning they hook into the runtime and get lots of cool information on CPU, disk, I/O, etc. without you having to do anything. Next, I'm pulling in the console metric exporter. I'm then configuring traces and metrics to go to a console exporter like so on an interval that I choose. This console exporter is just printing all of the information, all of the OTel stuff that we have collected to my terminal so that we can see it. Not very exciting. Now, let's get this using Heroku's telemetry drains with the Heroku OpenTelemetry collector to somewhere that makes this information a bit more useful. And by movie magic, we now have our brand new OTel file. Now, I haven't really changed much. I have set up now logs, metrics, and traces, the 3 signals, to all go to an OTLP, the OpenTelemetry line protocol. I have changed the exporters to be an OTLP exporter, the OpenTelemetry protocol for over-the-wire transmission. This will go to some drain of our choice where we can visualize our wonderful signals. Now that I've saved that, all we need to do is the Heroku famous git push. As you can see, no Docker files, no nothing, no kube control commands, just the simple, happy life. I can do a git add, git commit. I won't hate myself too much for that commit message, and a push. And we'll use Movie Magic one more time to skip the Heroku build. Okay, as you can see, it is now done. We can pop over to the Heroku dashboard where we can see this is finished. We can click Open App. We can zoom in. We can roll dice. Like so. Now what we want to do is make sure this telemetry data goes somewhere. Now it's important to point out here that when I add a telemetry drain, I am not deploying an OpenTelemetry collector. This is something that you would have to do with Kubernetes and any other traditional environment. But instead, we can use the Heroku CLI and run telemetry for my app, raw code, test, Node. And I should learn how to spell. And you can see there are no telemetry drains. Now, to configure a telemetry drain, I'm going to use Honeycomb IO. Now, as you can see, this is a new trial account and they are waiting for data. I have submitted nothing to Honeycomb yet. So let's go back to the terminal, run Heroku telemetry, app, raw code, test, Node. And this time we want to do telemetry add. And when we do this, we see we need some arguments, we run -- help. Now, we just need to provide the endpoint. We can also provide any headers to handle authentication to your OTPL drain, telemetry drain. You can suggest or you can tell Heroku which signals to send to the drain. And then you can configure the transport. This is either HTTP or gRPC over HTTP. And that's it. Now, I could type all this out, but I don't want to. I'm going to run just Honeycomb like so. And we can see that my telemetry drain has been added. So now if we run telemetry, raw code, test node, you'll see that my signals, traces, logs, and metrics are all going to Honeycomb, and this is the ID. As we can see from here, the command was telemetry add my application, the endpoint, the signals, the transport, and then my authenticated header. Perfect. And there we have it. We now have data inside of Honeycomb. All right, let's click on home. So at the top, let's change from the Heroku router to our application, which is where things should get a little bit more interesting. Now we can see our log messages, but we can also see that 56% is info with a 44% error. We can pop up, we can filter, and apply. Now we're just looking at the errors. And for some reason, warnings count as errors. As you can see, instrumenting your application with OpenTelemetry has never been easier. Not only that, when you deploy it to Heroku, it's also never been easier to collect that information and throw it to your data store of choice. So go forth, kick some tires, have some fun, sling some code. Have a great day.